Thank you, Molly. Hello, everybody. Thank you very much for joining us today at the DDN User Group. What I would like to talk about is some of the trends that we're seeing in the industry, not just HPC as we know it, meaning the labs and academia, and the scientific use cases that we've been utilizing and building machines for compute and interconnect and storage for, but some of the trends that are also happening in the industry. So enterprises which are starting to adopt HPC methodologies in order to develop capabilities, products, services, which make them a lot more competitive, give them a lot more insight into their businesses, and in turn result in, I would say, an IT methodology which is no longer just the domain of, well, I want my data to be safe and I want it to be replicated and I want it to be duplicated and all that, but really utilizing technology in order to accelerate time to insight and really achieve competitiveness at levels that were not possible before. So just briefly about DDN, I mean, we're still, somebody was telling me, well, you guys are no longer the world's largest private storage company because Dell and EMC is now private, therefore they're the world's largest private company. So I guess we're the second world's largest private storage company or something like that. But who knows what's going to happen as a result of that merger. I think it's going to be interesting to see how the product lines merge together and what ends up happening to the customers who are using those product lines. But anyway, we are still a private company, growing, profitable, self-funded, heavy emphasis on R&D. Our R&D continues to be driven very heavily by what is happening in the world of academia and government labs. I mean, we're finding that in order to develop a long-term vision for our products and technologies, core HPC is still the best place. So we're continuing to develop the products that we're developing based on the insight and the input that we're getting from you. So thank you for providing us that insight. And thank you for helping us continue to develop products that serve your needs, we hope, in the best way possible. We've been expanding across geographies, so these are all the places where DDN is present. I mean, the US is basically our core facilities are in California, Northern California and Southern California. Europe is really Paris. I mean, we have a number of other places in Europe, but our Paris office is expanding rapidly. We're making some fairly significant investments in the Paris office, tens of millions of dollars, and we're developing an advanced research facility in Paris. I mean, we're finding that European engineers are phenomenal. And so developing those capabilities in Europe, we have found to be really extremely enabling for us. So we've been staffing up and we're continuing to staff up in Paris. And then for Asia Pacific, Tokyo has long been one of our core facilities. We have a fairly large team of very, very technical people who are serving the region. So that's kind of what DDN looks like in terms of locations. So markets, I mean, these are things that I think you're all familiar with. I mean, unstructured data continues to grow. It grows in quantity and it grows in the usage of unstructured data in enterprises. And increasingly, enterprises are layering analytics capabilities on top of their data sets in order to provide products and services to their customers and to consumers at large at higher levels of profitability and higher levels of revenue. So that is something that, you know, started less than a decade ago and will continue to go on for several decades. The other thing that's interesting is we're finding that the very nature of data is changing in a significant way. Organizations now require levels of performance, availability, resiliency, and latency, which historically were only present in core HPC. And now we have quite a few customers in the enterprise, Fortune 500 organizations, large multinational global organizations who have deployed DDN solutions at levels which I would say, are larger by whatever metric you choose than what is done at the very top end of labs and academia. So that's a trend that's really interesting. And I think the reason that is happening is that the enterprise is finding that deploying solutions at very large scale is resulting in business benefits, and the ROI associated with it is just very easy to explain to a CFO. And I think that's why we're seeing these very large systems being deployed and adopted. At the same time, we are seeing a fairly significant trend towards end-to-end data lifecycle solutions. Customers are asking for the enablement of their workflows and applications as opposed to point products which solve specific problems. I mean, it used to be people were saying, well, you know, I need this much compute, or I need this much storage, and this is the capacity and this is the bandwidth. With environments becoming more complex, applications going into the workflow, and the need to really manage efficiency across a large number of applications in a distributed fashion, the end-to-end deployments are becoming more important. And so we're finding ourselves increasingly deploying solutions that leverage the various pieces of the product portfolio we have. So IME, as Molly mentioned, so as an application accelerator which leverages SSD and burst buffer. Flashscale, which we'll be talking about, which is a new SSD-based product we're launching. The SFA, which is now SFA 14K, and the ability to embed file systems and then put spinning disk behind it, and then WAS for collaboration, live archive, and the distribution of content. So all these pieces are coming together to help organizations manage their workflow end-to-end as opposed to just a piece of it. And so we're finding that HPC architectures, the things that have been happening in our market, in core HPC, are just ideal to serve the needs of the enterprise. And the number of times I walk into a customer facility in the enterprise and find a familiar face from a government lab or from a university, I mean, it's amazing. So they are hiring people from our world in order to be able to architect, deploy, and manage their IT infrastructures. And that's a fundamental shift which is also taking place. So, you know, organizations, I think the places where the adoption of HPC methodologies is growing the fastest, at least from our standpoint, from what we see. I mean, obviously, supercomputing, the HP is the top 500, which I guess just came out, and our market share has slightly grown. But the problem, I guess, that we have with the HPC 500 is the penetration and the adoption of DDN technologies by that market is fairly significant, and so being able to grow it in a very significant way is difficult. I mean, we're still north of 2/3 of the top 100 are using DDN technologies. More than 1/3 of the top 500 are using DDN technologies. But use cases which are finding that HPC methodologies are helpful for them are financial services. This is a fast-growing sector for us, life sciences, so healthcare, pharmaceuticals, and so on. And then, you know, web, cloud, and telcos. So that is really the ability to layer analytics on top of content and deliver products and services to consumers in a more efficient way, taking into account, you know, the global latency across a very distributed set of organizations. So Flash, I mean, I would like to talk a little bit about Flash. So Flash is everywhere. Everybody is selling Flash, but I mean, all Flash is not the same, and the use cases are different. So you have organizations selling Flash into the enterprise, and it's all about catering to the needs of databases, OLTP types of requirements. What we're finding is that in the world of DDN, Flash is really being used in areas where there's a need for significant scale in performance, and it could be as a layer on top of the file system, such as what we're doing with IME, or having the economics that are becoming really very, very interesting for high capacity SSDs. I mean, What we're finding now is that we are approaching the dollar per gigabyte for flash-based solutions at very high levels of performance. So think in one rack, 600 gigabytes a second, 60 million IOPS, and a price point which is rapidly getting into a dollar a gigabyte range. So it's becoming very compelling for large capacity environments to utilize flash and achieve significantly higher levels of performance than they're able to do with spinning disk, not to mention power consumption and reliability and so on. So, the problems that we solve is delivering performance to the application and delivering performance to the workload that is being utilized in the organization, as opposed to just a raw number that is fairly meaningless. What we found in what we've been developing on the software side that gets layered on top of SSDs is that it's one thing to have raw SSD drives delivering a certain performance level. It's something completely different to have that performance translate into what the application needs to see. So we've put a lot of work and a lot of time into developing the software layers that are enabling for SSDs. So you have file systems which were ideally suited to environments which have spinning disks in them. Conversely, we believe that there are different approaches that need to be taken in order to leverage what SSDs can do, both in terms of aggregating the performance of a large number of SSD drives, ensuring that the reliability of SSDs is being handled, because there are lots of issues around that, especially in write-intensive environments, but then tying that into a tier of spinning disk. Latency, again, we're finding that in our environments, in HPC environments, latency is a very big deal. So we've gone to great lengths to ensure that we have very latency efficient SSD-based solutions that we're deploying in conjunction with our embedded file system spinning disk solutions. And so what that really translates into is two pillars of technology for SSD for DDN. The first one is IME, which we've now been deploying since last year. And you can think of IME as really two things. One is an application accelerator and a kind of de-randomizer of a large-scale environment. So reordering kind of random IOs into more predictable behavior, which results in significantly better performance. And the other one is a burst buffer. So, a bank of SSD drives that is being managed by the IME software that sits on top of the file system, so that you can burst into that and then trickle into the file system. And we're finding that the economics are extremely compelling in these types of use cases because the acceleration that is taking place is very, very significant. And kind of the spikes that people experience in clusters are basically being masked by having this IME layer on top of it. So it's, again, de-randomizer, accelerator of applications which are not well behaved, and the ability to deliver significantly better performance and efficiency to the cluster. The other part of the portfolio is Flashscale, which we're introducing and will start to ship in the third quarter, which leverages our SFA OS engine and the platform of the SFA OS, but it is being deployed in all-flash arrays, which can combine NVMe as well as SAS. So you can have a piece of Flashscale which is pointing at large capacity SSD-based solutions that are read-intensive, so extremely cost-effective, high-capacity, read-intensive requirements, and another piece that is pointing at write-intensive requirements in the environment and delivers higher levels of reliability and high levels of performance. And those two things can be combined together in a Flashscale product. And in essence, what ends up happening is the same things that we were doing for spinning disks with the SFA technology starting more than a decade ago. We're now applying those same types of methodologies to this different media, which is SSD, which also comes in a variety of flavors. You know, back then it was SAS drives and SATA drives, high capacity, low cost, not necessarily very reliable SATA drives, and then higher performance SAS drives. Well, the same thing is happening today with SSDs. You have read intensive and write intensive. The price points are different, the capacities are different, but the ability to combine them together in order to address an environment which really needs both, we believe is very compelling. So these are some of the attributes of the Flashscale technology. Again, very high performance in 4U, 6 million IOPS and 6 gigabytes a second, which, you know, in a rack, you know, 10 of them, 40U, let's say, translates into 10 times that. So again, very compelling. And it's very high levels of performance at price points which are, we believe, extremely compelling. So again, for a high capacity solution based on Flashscale, it is approaching $1 per gigabyte without really having to have any compromise with respect to performance, latency, or scale. The ability to achieve high levels of capacity by putting lots of high capacity SAS SSDs in the Flashscale environment, and then, you know, great levels of latency because of the internal PCIe Gen 3 fabric that we've embedded into the platform. So mixing and matching, read intensive and write intensive, again, gives, we believe, the ability to manage environments very, very efficiently. And the platform itself, because it is a platform that we've developed for large-scale performance, low latency environments, also lends itself to being deployed for spinning disk types of applications. So again, the ability to combine all these things together in order to manage the end-to-end data lifecycle workflows that our customers are increasingly requiring. In terms of the applications, you know, what are the applications? If we look at the markets DDN serves, so the HPC markets, these are some of the applications that customers will be utilizing Flashscale for, and it really runs the gamut. There are so many use cases where SSD properly implemented and properly deployed can be greatly enabling to organizations. And the key is properly implemented and properly deployed. It's not just throwing a bunch of SSDs into an environment and hoping that things will go well. So that basically ends up coming into the environment as an additional tier. So again, if you look at the end-to-end, you know, at one end you have IME, which is really a burst and compute piece, which accelerates applications, provides a layer which sits in front of the file system. Then you have the file system piece, which is a combination of SSD, again, read-intensive, write-intensive, as well as spinning disk, with file systems, Lustre, GPFS being embedded into them, and then scaling in capacity behind that, and then tying into a live archive collaboration and distribution of content with our WAS technology, which then bridges into the cloud. I mean, we're finding that increasingly customer environments look like this, whereas even a few years ago, customers would come to us and say, well, you know, give me a rack of something that has file system and spinning disk, or give me something that handles collaboration and data distribution. Now, increasingly, I think organizations are looking at, you know, end-to-end. Give me a solution that manages my environment and my workflow in the most reliable, efficient, and cost-effective way. And I think that that's where all of this is leading to, even in core HPC environments. I mean, we're seeing these types of things even in, you know, very large-scale government labs and academia environments. So that's kind of the high-level view of how we're seeing things change. I think this is a very exciting time for HPC. I think it's extremely gratifying to see all the technologies that we've developed in our world here, the world of HPC, government labs, and academia, find their way into enterprises. And it's a wonderful thing to see, and we'll see a lot more of it in the years to come. Thank you, thank you.